Alright, welcome again in another tutorial of the topic differentiation. So, in this tutorial tutasoma kitu kinaitwa derivative as a rate measurer. Nishatengeneza tutorial inaitwa differentiation as a rate measurer, ni hicho tu. Kwa hiyo ni kama natengeneza topic hiyo kwa mara nyingine. Kwa nini? Kwa sababu mwanzoni pale tulikuwa tujasoma vitu vingi kwenye differentiation. Kwa sababu tumesoma vitu vingi, kwa hiyo nimeona nirudie. Hizi ni applications za differentiation, okay? Kwa hiyo moja wapo ni hiyo derivative as a rate measure. So, no maneno, twende moja kwa moja kwenye example. So, we have a conical vessel, a vessel with a vertical angle of 60 degrees. Kwa hiyo tuna vessel kama hii. Okay, it's a straight line. Okay, this is my vessel. Okay, with a vertical angle of 60 degrees. Manake angle hapa ni degree 60. Okay, so if liquid is poured into the vessel at the rate of 2 times 10 power negative 5 meter cubic per second. Meter cubic ni for volume, second ni for time. So that is just what? Jinsi ambavyo volume itakuwa inaongezeka, time inavyoongezeka. So ndio hiyo 2 times 10 power negative 5 meter cubic per second, okay? So maji yakimiminwa yanaongezeka kwa rate hii, okay? Find the rate at which the level is rising. Manake sasa hapa mpaka hapa ni height, okay? Height. Sawa. Kwa hiyo nikimimina maji yatakuwa yanaongezeka, Kwa hiyo h itakuwa inaongezeka, height ya maji itakuwa inaongezeka, okay? So find the rate at which the level is rising. Kwa hiyo rate at which the level is rising itakuwa ni dh dt. This is all we're told. When the depth of the liquid in the vessel is so maji tayari 0.5. Kwa hiyo vessel kabla hata jamaa hajaanza kumimina maji kwenye vessel tayari maji alishakuwa na kimo hiki hapa, okay? So akaongeza sasa hiki kimo kina mata, okay? Kwa sababu jinsi unavyoona kwamba hapa ni panene kuliko hapa, okay? Na hapa ni panene pia kuliko hapa. Kwa hiyo maji yakiwa na level hii ukiongeza dHdt itakuwa sio sawa na maji yakiwa level hii ukaongeza, okay? That's why the level of water here is essential. So we just need to find that one. So this one is a cone, okay? So let's look for it now. So I know that the volume of a cone is just 1/3 pi r squared h. This one is the volume of a cone. 1/3 pi r squared h. Lakini wana cone yetu sipo hivi alafu hivi, sawa? So this sasa is a h, nimechora katikati. Okay, this is going to be 30 degrees and this one is also going to be 30 degrees. So this one is our r and now urefu huu sasa is our h. So you can just see hapo ni ipo hivi. Okay? This one is h, this one is 30, this one is r. So tan of 30 is equal to what? Is equal to r over h. So you can see that r is just equal to h tan of 30. But what is tan of 30? Tan of 30 is just equal to radical 3 over 3. So r is equal to this one. So now my volume now, so okay, this r I can square it. It's just going to be r squared is equal to h squared. Then this one is 3 over 9. So this one is just h squared over 3. This is r squared. So my volume now is going to be 1/3 times pi. R squared now is h squared over 3 times h. So my volume now is just going to be equal to 1/9 pi h cube. So this one is my volume now, okay? So, kwa hiyo volume yangu ni hiyo pi over 9 h cube. Sasa nina dv dt From chain rules, it's just dv dh times dh dt, okay? So this is true. So from here, I can get dv dh from here. So dv dh, kumbuka pi na 9 na 9 ni constant, because it's just going to be pi over 9. Then I differentiate h cubed with respect to h, which is just 3h squared. So 3 goes, here remains 3. So my dv dh now is just going to be equal to, pi over 3h squared. So this one is my dv dh. So now my dv dt is equal to, dv dh, which is pi over 3h squared times dh dt. So this one is a rate of change of volume. So this one is just 2 times 10 power negative 5, okay? Meter cube per second is equal to pi over 3. So what is h? The depth of the liquid now, okay? You see, it matters, it's 0.05. So we're going to find at what rate is the level, right? And we're going to find dh dt. So what do we have there? We're going to have 3 times 2 times 10 power negative 5 over, we're going to have pi times 0.05 squared, like this. It's just going to be equal to, kumbuka ile ni h squared, okay? It's just going to be equal to dh dt. Kwa nimegawanya, okay, pande zote. So kwa juu itakuwa ni 6, okay, times 10 power negative 5. So pi is just 22 over 7. When I square this one, I get 0.025, okay? It's equal to dh over dt. So it's just going to be 7 times 6 times 10 power negative 5 over 22 times, this one is 2.5 times 10 power negative 3. So what do I get there? 7 times 6, this now is dh dt. So 7 times 6 is just 42 times 10 power negative 2 over 22 times 25, which is just 55. This one is just 55 times, okay, negative 5 minus negative 3 tunapata kule juu negative 2, kwa hiyo nimeshamaliza hapo. Over 25 is equal to dh over dt. So this is just 42 divided by 55 times 10 power negative 2 is equal to dh over dt. So when I take 42, I get 0.764 times 10 power negative 2 is equal to dh over dt. So this one now is the rate at which, so okay, let me just conclude it, okay? So my dh dt, I say my dh dt is just equal to 0.764 times 10 power negative 2. So this one is meter per second, okay? So kwa hiyo height itakuwa inaongezeka kwa level hiyo, kwa case, kwa ile case ambayo tumepewa pale. Okay. So, naweza nga simplify further, it's just going to be equal to 0.00764. Yeah. Now let's see another example, okay? You're going to bear with me because I'm going to write it. It's called example 2. So example 2 says the radius of a sphere is r. The area of its surface is 4 pi r squared, and its volume is, this is a sphere now, not a cone. Ile tumetoka kufanya ni cone. It's 4 over 3 pi r cube. If okay, when the radius of the sphere is 21 meter, it is increasing at the rate of 0.01 meter per second. Okay, so that is the rate of increase of the radius. Find the rate at which the surface and the volume are increasing at the same time. Kwa hiyo umepewa sphere, okay, ina radius r, area yake ni hii, volume yake ni hii. Radius yake ni 21, okay? Alafu hiyo radius ina increase at a rate of 0.01 meter per second. We'll find the rate at which the area is increasing and the rate at which the volume is increasing. This is what you are required to do here. So let's get to work. So tuanze na area. So area is just equal to 4 pi r squared. Kwa hiyo bila shaka, the rate at which the area is increasing, you can just obtain it by chain rule there, dr times dr dt. So this one I can get it here, okay? So my dA dr, so 4 pi ni constant, na differentiate 2r squared, napata 2r. So it's just equal to 8 pi r, okay? So my dA dt now is just going to be equal to dA dr times dr dt. So my dA dt now is just going to be equal to 8 times pi and 22/7 times r and 21. Remember, times dr dt is 0.01. So this is 1, this one is 3. Okay, so multiply there, what do you get? Okay, this one is just going to be what? 176 times 3 times 0.01. So kichukua 176 times 3 ni ngapi? Sina calculator hapa, I'm going to do it hivyo. So it's going to be 8, carry 1, 2, you carry 2, 5 times 0.01. So the ADT is just going to be equal to 5.28 meters squared per second. Okay, kwa hiyo unit ya huyu per unit ya huyu, okay? Ndio hiyo. Meters squared per second. So this one is the rate at which the area will be increasing. Kama radius will increase at this rate. At 0.01 meter per second, the area is increasing. So now we have a volume now. Tafute na volume. So volume inasema yenyewe is just equal to 4/3 pi r cube. Alright. So we are looking for dV dt. So it can just be obtained by chain rule hapo ni dV dr times dr dt. So hapa naweza nikapata dV dr, it's just going to be dV dr, it's going to be e4/3 pi ni constant, kwa na huyu hapa, na differentiate r cube, na pata 3r squared. They go. So my dV dr now is just going to be equal to 4 pi r squared. So my dV dt now is just going to be dV dr, which is 4 pi r squared times dr dt. So my dV dt now is just going to be equal to 4 times pi is just 22/7 times this one is just 21 squared times dr dt is 0.01. So dv dt now it's just going to be equal to 4 times 2 is 88. Huyu nikigawanya kwa huyu nabaki na nini? Times 21 moja itakufa itabaki 3. 3 times 21 is just going to be equal to 63 times 0.01. So my dv dt now itakuwa ni ngapi? So I'm going to take 88 times 63. It's very difficult and I don't have a calculator. Okay, so 88 times 63, let me find. You're just gonna get 55. I mean, you're gonna get whatever. 88 times 63. So sorry about this, guys. This is 4. You carry 2, 24, 26. 8 times 6 is 48. You carry 4. 48 plus 4 is 52. There. So we have 4, 4, 5, 5. So we're going to have 5, 5, 4, 4 times 0.01. So dv dt now is equal to 5, 5, 4, 4 times 0.01. It's just the same as what? 55.44 meter cubic per second. Okay, so this one is the rate at which the volume will be changing of the sphere. So that is about derivative as a rate measurer. Let me just say, see you in the next tutorial where we'll be exploring more applications of differentiation. So tunakaribia mwisho wa hii topic.